Gigabyte X670 Aorus Master slots and storage. And this is going to be a little bit more about possibilities and limitations, because as we look at and let's establish our platform, we're talking about a consumer desktop motherboard, and some of the references we're going to make are going to be according to a high-end desktop, which has kind of gone flat, and a workstation, and it has some of those features have trickled down to do what we're trying to do with slots and storage, because it's all about two things, and that is PCI Express lanes. We have to divide, we have to look at the motherboard, CPU, and chipset as we sort this out, because there's a couple of features on here, one added, one removed, but again, you've only got so many resources. They're shared resources on the consumer desktop motherboard. So the two things we need to divide out are, as we reference this high-end desktop in front of us, which is a Gigabyte TRX40 Designaire, to reiterate, CPU PCI Express lanes and chipset PCI Express lanes. Now, we're going to go through the same scenario we did with the last time. We're going to do three types of add-in cards. One, a quad card, because we've had over 1 million views, and I want to thank you for that. I love my subscribers. Number two, about a possibility of a video card, the GPU. And number three, the other add-in card that everybody's excited about, USB4. So as we look at those three different scenarios and we outline how these lanes are all allocated, if we're looking at the first scenario of a quad card, which could be like this machine in front of us, we could be PCI Express 3 or PCI Express 4, or on this new platform, could be PCI Express 5. And yes, Gigabyte has announced PCI Express 5, which will be the Gigabyte Aorus Gen 5 AIC for add-in card. So to reiterate, whichever one of these three you want to put in the machine, which is probably a year off, same with the USB4 card, we'll get into that. If you choose to go with something that's available right now, it's all going to be about two things. One, how many CPU PCI Express lanes do you have? And number two, can we fully bifurcate those lanes in the BIOS like this machine? And this makes a good example. Okay, we've had questions about the slots as well as we get into questions about the storage. So to reiterate, the Gigabyte TRX40 Designaire, where we have 4 slots, all these mechanically, which would be physically, are 16-lane slots. However, electrically, or according to actual PCI Express lanes allocated, we have 2 16-lane slots, and then we have 2 8-lane slots. And in this second 8-lane slot, we have a Gigabyte Titan Ridge Thunderbolt 3 add-in card, which is only using 4 lanes. So that's in an 8-lane slot. Using 4 lanes, we lose 4 lanes. But these are all dedicated resources. And for the M.2 drives, we have 2 under this video card. Both of those are to the CPU. And the other 2, which are under one heatsink, those 2 M.2 drives, M.2 NVMe specifically, those are routed through the chipset. So we have 2 to the CPU, to reiterate, 2 to the chipset. And why is that important? Well, a lot of people that want to do the first scenario, which would be adding in a quad card, we'll address the video card and the other stuff, but one thing at a time, where you have 4 M.2 drives, and generically on this motherboard, as with most of these, you got 3 slots, 4 M.2 drives. So we got 2 M.2 drives that are wired to the CPU, and we got 2 M.2 drives that are through the chipset. Now, in RAID, you can RAID those together, but I would not, because they're going to be difference in speed. As we look at the speed of the 3 different places where an M.2 drive could be located, number 1 would be directly wired to the CPU. Number 2 would be on a slot directly wired to the CPU. And number 3 would be on through the chipset. Now remember, we've had one chipset in the past. A long time ago, we had a North Bridge and a South Bridge chipset. And going forward with the X670 Extreme chipset, we're going to have 2 chips that make up the chipset. So we have resources allocated to the CPU lanes. We have resources allocated to the 2 chipsets. So many lanes in one chipset and so many lanes in the second chipset. Dividing those out. Now, something I'm always curious about, and Max is calling my hand on this, and rightly so. Okay, there's 2 numbers we're looking at for CPU lanes. One, we have what's the usable lanes, and I'll show you some documentation that will be in a link in the description for the video from AMD. We also have an article from Tech Power Up that reiterates and reinforces that information, because we're looking for congruent information. The more information we have, we build a body of evidence of what we know to be true. Okay, based on that article from Tech Power Up, it's quoting a presentation that AMD has done about lane allocations. So whenever we see anything that AMD says about PCI Express 5 lanes, those are CPU lanes. And that's what we have to the CPU. 1 slot, PCI Express by 16, with 16 lanes allocated to that slot. and 2 M.2 drives. So if we do a lane count, what would be defined, or what they call usable lanes, because we're talking usable lanes versus total lanes, and I'm really curious about the total lanes. I get close, but I got to tell you, I've counted a lot of this stuff over 100 times. How many times can you count to 24? And how many times can you count to 32? Sometimes 31, 32, some fuzzy math. But the more I look at this, the more I realize how little I know, and the more I want to understand it. So we're going to, again, to reiterate, on the CPU lanes, we're going to look at the usable lanes. As we've just outlined, that's 24 lanes. So if you have a 16-lane slot like we have here, and you have 2 M.2 drives, that's 16. And remember, because we're going to bifurcate that, we're going to put 4 M.2 drives on that add-in card. That's 4 lanes per drive. 4 of them is 4 is 16. So 16 lanes plus 4 is 20, plus 4 more is 24. Those are the lanes. So we're going to go through the motherboard. We're going to look at the specifications. We're going to look at the motherboard layout. We're going to look at the block diagram, which we have. And that's been the big advantage of looking at all these motherboards from Gigabyte that we have documentation. Now, we've been looking at ASRock because that's been in our radar as well as everybody else I'll get to in a second. Anyway, ASRock has a motherboard manual, but we do not have a BIOS manual. So one little feature that's required to do that number one scenario, which would be an add-in card, we know the slot is there, and we know there's 16 lanes on that slot, and we can look at the motherboard block diagram and see how that's allocated. But what we don't know is bifurcation. Is bifurcation supported on the ASRock motherboard, which would be the Tai Chi and the next one down the line that we've been looking at, not just the Tai Chi Carrera, which is the same motherboard. It's a difference in the Tai Chi versus Tai Chi Carrera, which is like Carrera Marble. But anyway, the other motherboard that they're talking about that's been listed, same information. Generically, 3 slots that once we go through, you'll understand when I say generically, 3 slots based on whether it's actually a device that plugs into the slot because of the other devices we're going to talk about, or whether it's the actual slot that's available. It's going to have to require an add-in card. And then to reiterate, 4 M.2 drives. How are those wired? Okay, we're going to look at 24 lanes. We'll go through that real quick. This should make it easy. And I'm hoping as we do this, the more we do this, it'll help you understand. So as you take back a step or two and look at a motherboard like this, you can be more critical on what you're looking at and not so emotional about the things they're pushing in front of you. Because it's always about slots and storage, and it's always going to be about possibilities and limitations. Because remember, all these connectors that they're putting out there in front of you to make your mouth water does not mean you can use all of them, because it's give and take. When you're on a consumer desktop motherboard with limited resources, shared resources, it's not like dedicated resources like we have, or dedicated resources like you would have on a workstation, because a lot of the things you guys want to do require a workstation. So as we look at this and evaluate this chipset, my opinion right now is not real high what we get. 3 things with this new chipset. It's the Extreme chipset, so it's about PCI Express 5. And we've just learned now, according to an article from Tech Power Up again, that the RTX 4000 series, 2 things to be thankful of, or to be thinking about. Number 1, those cards, those video cards, those GPUs, are not going to be PCI Express 5. They're going to be PCI Express 4. But they're using a power tap based on PCI Express 5, which only allows for 30 insertions. And I didn't know this, but that's been the spec for all the GPUs, 30 times on that connector for the insertions. I got to tell you, as many times as I've been moving video cards around to do the videos to share with you guys about how this stuff with slots and storage works, I'm probably past my limit. I didn't know that, didn't realize it. It used to be, a long time ago, the limit we were concerned about was how many times can you update a BIOS. And I don't remember, and if I give you a number, that doesn't mean it's right, but I want to say it was around 30. It was either 30 or 50, but we're talking a long time ago when we started getting a BIOS that we could update, because BIOSes used to be hardwired. Once they were set, that was it. So when we got a BIOS that we could update, we were concerned how many times we could update it. We never hit the limit. We never hit the wall. But there was a limit. So now we know, we've been reminded to reiterate the limit on how many times you can plug and unplug a video card. It's 30. I'll get the link up on that information as well. I think it was, again, Tech Power Up. So as we go through this manual and as we look through this information, things that are going to pop out for you that you're going to see that this is the kind of stuff that, like, you know, you look around, you look at a motherboard, everything gets kind of fuzzy because they all look alike. You're looking for something pretty. We're always about function, not about form, because Everything we focus on is content creation for rendering, and rendering requires processing power. And I hope after you get through with this video, for those of you that are going to stick around for this, you're going to take a more critical eye as what you're looking at for a consumer desktop motherboard versus a high-end desktop, which was beautifully perfect for everybody that's been squashed to the Workstation, which is alive and well, but it's PCI Express 4. But as you look at the limitations, and I'll tell you right now, some history going back, we've always looked at hard drives on a price per megabyte. So on that price per megabyte, we would run the numbers to see which drive made the most sense versus the capacity and the price, because it didn't always equal out until you did the price per megabyte, and that's what made sense. Okay, on a Workstation, we know how much a CPU costs based on a price per CPU core. I'm going to propose another option for you that I think may be even more applicable on the consumer desktop motherboard, because you're limited, you're stopped at 16 CPU cores. And we know there's been 4 CPUs announced. I'll see if I can find the list. I'll put it up for you. But based on the number one CPU that's got 16 cores, how much is that CPU going to cost you per, not core, but per lane? Think about that, run the math once we find the prices, and you can determine, is this a good place to be on a consumer desktop motherboard, or are you better off on a Workstation when you look at the price per lane? And we're doing this based on CPU PCI Express lanes and then chipset PCI Express lanes. And we have 2 chipsets. Now, for the usable lanes, to reiterate that, we're looking at a number of, I believe they're telling us 24. I've outlined that. What I've done, because I'm curious, I think there's 32 there, but something's off because the lane allocations for every motherboard I've looked at are different. And the numbers you're looking at for the chipset, for those 2 chipsets, look like also 32, which would be 16 and 16. Okay, based on the information I'm going to share with you, it looks like the primary chipset is going to have 8 usable lanes, and the secondary chipset is going to have 12 usable lanes. So we'll count to those numbers based on slots and storage, and then you can look at what the rest of them are, because I also like to list the high value targets are items that use a lot of lanes. Like we're looking for not only USB4, which I'm going to get into version 1 and 2, but we're also looking for 20 gigabit USB-C, which uses 4 lanes, or 10 gigabit Ethernet, which also is supposed to use 4 lanes, but depending on the chipset, if it's Intel, 4 lanes. If it's Marvel, depending on how it's allocated, could be 2 lanes, could be 4 lanes. It depends. But all these little details, as always we say, you change one thing, changes everything. Details matter. Let's get into some of the nitty-gritty. Let's establish first what we know to be true, and this is an article from AMD, where AMD launches the Ryzen 7000 desktop processor, and this goes back to the date of 8/29. We're looking at a 16-core processor, the Ryzen 7950, so 16 cores, and the 4 CPUs we're looking at, to reiterate, 16 cores, 12, 8, and 6. And another issue we're going to have to address as we get into the 3 different types of slots will be what kind of video these are going to have on board. These are all PCI Express 5.0, and this has a list price of $700. So do the math and see what that's going to work out to on a price per CPU lane. And the new AMD socket AM5 updates. The AM5 platform includes up to 24 PCI Express 5.0 lanes. Okay, to reiterate, when we're talking PCI Express 5 lanes, those are CPU lanes, because everything going into the chipsets, which we're going to get into and I'll show you, but I want to establish so you understand as we go through this, so this will all make sense. And I know Max will appreciate this, or else he'll say, hey Gil, I can hear him putting his thumb on me and whispering in my ear. So 24 PCI Express 5.0 lanes, which are CPU lanes. Anything to reiterate through the chipset is going to be PCI Express 4 or PCI Express 3. It matters. Let's go to the next article on Tech Power Up. Okay, here we are. Activity on the processor, and they say 28 lanes. And I've counted a total of 32. So I can live with that. Let's do the math. The first lanes will be to a single slot, or they can be split to 2 slots, which would make them by 8 by 8. And the PCI Express 5 is only going to be, to reiterate, on the X670 Extreme motherboards, which means, as we said, PCI Express 4 will be on the lower cost motherboards. PCI Express 4 is through the chipset, even on the X670 Extreme. To reiterate, the X670 Extreme has PCI Express 5 on the CPU lanes, of which they're saying now there's 28. So 16 for the slot, 2 M.2 drives, that's 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 lanes. So what are the other lanes we're talking about? Let's look at the article again from what AMD says, and AMD says 24 lanes. So I can live with that. You want to call those usable lanes or lanes that can be, I think it'll be easier to understand as we look at the block diagram, because I got to tell you, looking at all these motherboards and all these block diagrams, we've seen stuff from BioStar, and BioStar doesn't have enough information out yet to fill a thimble. But based on the features and based on the, I got to interject this, descriptions, which again we need more than just specifications, the next two to look at are going to be ASUS and MSI, but we need those manuals. No manuals yet, so I don't know what everybody's afraid of. So the best documentation right now we have is based on what Gigabyte's put out. And ASRock has some really good documentation as far as what they've given us on the motherboard, but still nothing about the BIOS. So if we go ahead and proceed to do the video about what we know on the ASRock motherboards, I think it'll be helpful, but again, we don't have everything. So number one, consider the source. I'm not perfect. I'm telling you what I know, what I've discovered, what I've seen, and it's up to each of us to test and verify. No matter what anybody tells you, always consider the source and always look at the information you're coming across. So I want to show you what I found, and we're going to compare it with what we know to be true based on what AMD is saying. And remember, Tech Power Up, they're getting the information from what they've been told, because all this stuff is new. It's not like you can say, hey, AMD, wait a minute. Could you go over that point one more time? We don't get that chance. That's what we're doing now. And that's what we all need to do before we make a decision that we want this or we want that. And my goal is to convince you why you want to go beyond this, but based on what you're getting, what you're not getting, that you would like with a workstation, because that's what a lot of you want. All the questions we get. Like I said, to reiterate, we've had over 1 million views. We've had a few videos. We had one in particular with over 100,000, and that's all it deals with is slots and storage. And even with the questions, based on things I've said today, I've changed some of the things I've said based on those questions so we can answer it to help as many people as we can. Because I love looking at this. Every one of these motherboards is absolutely fascinating. But the resource allocation, it is so complicated and convoluted on a desktop motherboard how all this works. So let's keep going. Now, since the term is used, I'll go ahead and use it here. Promontory 21 is the terminology used for the chipset, which will be, and you'll see this if you look at the ASRock documentation, Promontory 21, which is I want to call it the North Bridge and the South Bridge, but it's being referred to as a chipset, or first chipset and secondary chipset. Anyway, there's supposed to be a total of 16 lanes for each one of those. And the first one, according to this article, is going to have 8 usable PCI Express lanes. And the second one is going to have 12 usable PCI Express lanes. This is fascinating stuff. Talks about 4 of the lanes are going to be PCI Express 3. We'll be able to see some of that as we identify and look at the block diagram. To reiterate, the block diagrams are significant, and I've looked at so many of them, and I've been able to take a more critical eye where I could step back and say, okay, this is how this block diagram is seen, and this is how this block diagram is seen, and this is how this block diagram is seen. The point of it being, all 3 of them are different. It's as if we need a key like a map legend that we don't get, that I'm hoping what I'm going to share with you, because some of them read left to right, some read top to bottom, and some read what they want to call shared resources based on the right, and other resources that are there that we don't normally count that are on the left. It depends on which map we're looking at. But I like the map we're going to get, and I like the lane associations we're going to see with what we have with Gigabyte. So to reiterate, we've established our lane count for what's defined as usable lanes. Let's go now and take a look at the motherboard, which is, to reiterate, the Gigabyte X670E Aorus Master. Key features, cannot ignore, and right here under connectivity, rear and front USB-C 20 gigabit. It's got the Intel it's got 2.5 gigabit LAN. We'll check on the chipset. But the biggest thing here is the USB-C 10 gigabit with DisplayPort Alternate Mode. And that's the feature I've been eager to tell you about, but I had to tell you about all this other stuff that's on this motherboard that was not on the Extreme motherboard, but to reiterate, is on the Master. Now, this motherboard does not have the 10 gigabit Ethernet, but remember, 10 gigabit Ethernet requires 4 lanes. So those lanes have been reallocated, we're going to get into. But for those that want of the 3 features that we can have with USB-C, because we're going to have 10 gigabit USB-C and we're going to have 20 gigabit USB-C. And then we'll get into the speed of the 40 gigabit and the 65 gigabit with USB4 in just a second. But as we're looking at those 3 features, number 1, data delivery, number 2, power, but the third option that was originally introduced some time ago, then removed, now has been brought back in a big way, is this feature with DP Alternate Mode, which is DisplayPort Alternate Mode, which means, and this is really important, because we've talked about putting one add-in card in the computer in that first 16-lane slot, which we've still got to look at. But when we get to option number 2 that I need to talk about now, if you're going to put a video card on that machine, then you cannot have a quad card of any kind. You have to think about that and let that soak in. And the other 2 slots are not going to have the resources unless you don't mind it being in a 4-lane slot. We'll get to, but we'll double check. Okay. And if this motherboard had 2 8-lane slots, you still would have difficulty putting in a quad card. We get into that all the time because then you've got, yes, your GPU can be in an 8-lane slot, but then you're talking about an 8-lane slot for a quad card for 4 drives, plus you've got to have full bifurcation. And if you're in an 8-lane slot, you're going to see 2 drives. And if you don't get full bifurcation, but you get 8x8, guess how many drives you're going to see? You're going to see 1. It happens all the time. But with full bifurcation in an 8-lane slot, you'd see 2 drives. All these details matter. But for this one feature, for people that want that, why is this important? Doesn't matter if you have a separate GPU. And I believe the details on this are a little bit clearer, a little more concise, a little bit better spelled out with ASRock. If you want to use the DisplayPort Alternate Mode, which means you can have video out that port, that's coming from CPU lanes. Where do you think the video is coming from? That means you've got to have a CPU that has video on board. Can't be used with an external video card. Why? There's no way, just like Thunderbolt, to route the video out of the video card back in. Therefore, the only way you're going to get video out of that port is if you use a CPU that has video on board. Talked about some of that in the last motherboard on the Extreme. It did not have this feature, but it had the ability for the CPU to have video on board. So there it didn't matter. Here it does because of DisplayPort Alternate Mode. So I'm sure we're going to be talking about that a whole lot more because it's a big deal. And if it's supported, they'll tell us. So I'm telling you now, that's a detail. Okay, that's in the features. We're going to see more of that. And up here on the connectors, that is the USB-C, and you can barely read it, but that's DisplayPort Alternate Mode. On the primary, there's the secondary, which is USB-C 20 gigabit, and there's the 2 connectors to get video out of the video that's on board. In other words, to reiterate, a CPU that has video on board, video comes out of those 2 connectors. And the third connector is the USB-C connector that we're looking at right now, which will give you that USB-C on a monitor. You should be able to put an adapter on that, but I don't know that for a fact, so don't quote me, which means you could convert it to HDMI if you need to, but I don't know that it will. I don't know that it'll pass the information. It should, but that doesn't mean it will. But always change one thing, changes everything. Now let's go look at specifications right quick. Okay, we're talking a Ryzen 7000 and a socket AM5 AMD, the AMD X670 Extreme Chipset, DDR5 up to 5200. And I have to mention this. This is for dual channel 128 gigs. Now, we don't get asked about this a lot, but this matters in terms of the formula for content creation for rendering. There's one formula that's the best formula we work by, and whatever your render engine is what you need to consider, which takes into account for CPU cores, total amount of RAM, and total amount of video RAM. Those 3 items we can come up with in 2 specs, and that's the Adobe After Effects Multi-Frame Rendering CPU Optimization Formula. And no, we don't use Adobe software, but the Adobe formula is the best we've seen. It's better even than the stuff that Blackmagic puts out about their formula, which states, number 1, CPU cores times 4 equals RAM. So if you've got 16 CPU cores, because you're on a Consumer Desktop Motherboard, how much RAM do you want to put in that machine? If you got 16 CPU cores, you want to put in 64 gigs. And this is a fascinating aspect because we're talking 32 gig DIMMs. So 32 and 32 is 64. 2 sticks, dual channel, you're set. Number 2, CPU core count equals video RAM. So if you're using onboard video, then because you want to use that slot for a quad card that requires 16 lanes, if you use onboard video, then you want to set the aperture for the memory in the motherboard BIOS for 64 gigs, or somewhere below that based on that formula of 16 CPU cores and 16 gigs of video RAM, VRAM. You got your options, take your pick. Now, if the data model of the data set that you're working with cannot work within 16 CPU cores and it's a limiting factor, then you need to be looking at another machine like a workstation. If 128 gigs of memory on 4 DIMMs is not enough, because this is dual channel, then what you're looking at is a workstation PCI Express 4, but it's 8 channel. Now, we've had dual channel for more than 10 years. We've had 4 channel on the high-end desktop, which has now gone flat, and that's been, what, about 3 or 4 years now? So having 8 channel for the last couple of years on PCI Express 4, even if you're talking based on the density of the DIMMs, you can easily get up to 512 gigs. And as far as CPU cores, just to get on the platform, if you start with 16 CPU cores, my point is, even though you're a 16 CPU core, you stop here. Up here, you can come below that, but if you're looking at 16 CPU cores, you still have room to upgrade. With memory, you still have room to upgrade. With PCI Express lanes, you still have room to upgrade. So scenario number 1, a quad card. You're better off putting a quad card up here, but you can do it here. But you can't have a GPU. So scenario number 2, because of DisplayPort, the GPU won't matter. You've got to use a CPU that you hope is 16 cores, that has video on board, that you hope you can set the memory aperture to equal your CPU core count to your video RAM, that it will complement, so that if you're doing rendering, if you're doing CPU-based rendering or GPU-based rendering, you'll get a formula where you get a purpose-built machine that's all about function. Function number 1, so this thing will do what you want. But I will put this forth now. Anything you build on a consumer desktop motherboard is about a 2 to 3 year computer. Whereas if you build a workstation, high-end desktop or a workstation being the better value, you're able to build a machine that's going to last, have some longevity. It's going to cost more, but it's going to last longer. Because a lot of situations we get into, somebody will ask me questions where they've got so many slots and so many resources and it's not enough. And then we try to evaluate, because we're talking about, again to reiterate, the consumer desktop motherboard, where you have a fixed amount of PCI Express lanes, where they'll want to take another slot to try to add more storage, and we have to sort it out, that you go from then a motherboard that can bifurcate that slot to 4x4x4x4 to do 4 M.2 NVMe PCI Express drives, to a slot that's at least 8 lanes, where you can then add 4 drives on a self-bifurcated card. The point I'm telling you this, the price of this motherboard, by the time you add that self-bifurcated card, you're at the price of this motherboard. So you spend it now, or you spend it here and spend a little bit, and you nickel and dime. You're still limited. You've got options, but you're limited, and we try to go into those because we talked about all these different quad cards that are requiring motherboard bifurcation or the ones that are self-bifurcated. And what we try to do for clarity is lay out the 1, 2, 3. So now, there's a third option I want to get into, which is the add-in card for USB 4. Now, depending on who's marketing and what they're telling, USB 4 could be the AS Media chipset, and AS Media on this Promontory 21 worked with AMD to develop this chipset, which is pretty wild. So you're going to be seeing a new chipset from AS Media on motherboards for 20 gigabit USB-C, and maybe for that DisplayPort Alternate Mode. But right now, DisplayPort Alternate Mode, based on what we've seen, is using CPU lanes, not chipset lanes. So let's go back to the specs. I've covered RAM. Let's keep going because we got a lot of stuff and I want to get through this and keep this tight. Okay, so much for memory. The AMD profiles can be either AMD Expo or the XMP like we're used to. And that's reading the SPD serial presence detect chip, which is on the memory. Integrated video, to reiterate, the USB-C port. And that gets a respectable 3840 by 2160 at 144 hertz, which is pretty wild. And the graphic specifications may vary depending on CPU support. Remember, to reiterate, you've got to be using a CPU that has video on board to be able to use that connector, DisplayPort Alternate Mode. So all these little details, do one thing, changes everything. So yes, details matter. Okay, going on down the list. Not such a big deal with audio, but for those that might be using this for a digital audio workstation, and I think this is relevant. If you're going to use this for a digital audio workstation, you don't give a squat about the audio that's on the motherboard. You're going to be using something separate. So the number one thing you want for a digital audio workstation is an audio interface, whatever you use. If it's USB 4 or if it's, I'll propose, USB-C something. And I think USB-C being the lowest common denominator. Anyway, you want something that's got low latency. Okay, you've got 3 possible places where you can plug that in. But you have a choice. If you're going to use that USB-C port that's to the CPU, that's 10 gigabit, that's DisplayPort Alternate Mode, well, guess what? That's it. You can't use it for anything else. So if it's going to be used for audio, that's going to be the lowest latency. If you go for the one through the chipset, either one of the chipsets, 20 gigabit USB-C, you've got more bandwidth, but you got possibly more latency. Again, test and verify, but it's something to be aware of. So 3 different places to have a USB-C port. Which one do you think is going to have the lowest latency? Based on M.2 drives, we know the CPU is the lowest latency. We know based on tests we've done with M.2 drives on the CPU versus M.2 drives on the chipset, like in this system, the ones to the CPU are the fastest. The second one, to reiterate, are the ones on the quad card if I had it in here. And number 3, the slowest, will be the ones that are through the chipset. So my point is, if I were to RAID, I would RAID these 4 and these 2 together because they're to the CPU. They're using CPU PCI Express lanes. But even though I could RAID the 2 through the chipset and the 2 through the CPU, I would not, because there's going to be some latency that's going to slow these 2 down. Okay, something else we need to think about. What's the speed of the PCI Express lanes to the CPU? PCI Express 5. And what's the speed of the lanes to the chipset? PCI Express 4. So if you're going to put, like on a machine like this, where you've got 2 and 2, just like up here, to reiterate, 2 to the CPU, 2 to the chipset, these 2 are the fastest, not only because they're to the CPU, which have the lowest latency, but because they're PCI Express 5 versus these, which are PCI Express 4. Wow. Okay, what's the speed we're talking about? I expect, just like with PCI Express 4, we're going to see 3 versions of PCI Express 5 M.2 NVMe drives. The first generation, first of all, the spec is good for 15,000 megabytes. So the first generation, and that should be third generation. The first generation, to reiterate, is probably going to be 10,000 megabytes. Second generation, I would hope around 12 to 13. And the third generation would be 15,000 megabytes. It's all about fine-tuning and getting the right controller with the right kind of memory to make that snap. So for that one reason of PCI Express 5 versus PCI Express 4, 2 to the CPU and 2 to the chipset, I wouldn't RAID those 4 together for that reason alone. Number 1, because of the difference in the latency, but number 2, because of the difference in the speed of the drives. Big difference, big time. And if you're dealing with PCI Express 3, those are good for about 3,500 megabytes per second. And how does NVMe on PCI Express 3 compare to, say, SATA? Which brings up another question about SATA drives versus M.2 NVMe drives. A SATA connection can do on an SSD 600 megabytes. So 600 megabytes on SATA 3 versus PCI Express 3 for 3,500 megabytes. 3,500 megabytes versus 600 megabytes. And yes, we're talking not throughput, but we're talking burst mode. Burst mode versus actual throughput. So bandwidth is an interesting target, but we work according to the specs. So keep all that information in mind as we stir the pot. Back to the specs. And we're trying to keep this short, but keep it to the specs. Okay, we're using Intel 2.5 gigabit. Nice. To reiterate, no 10 gigabit. Bummer. If that matters, then that could be a deal killer. If it doesn't matter, and your priority is DisplayPort Alternate Mode, then this is your motherboard. Intel Wi-Fi 6E AX210. That takes up one PCI Express lane in case you're wondering. Now for the slots and the storage. We've still got our third scenario to go through. We've been through 1 and 2. Okay, we have one slot to the CPU. It's a 16-lane slot mechanically, but it's also PCI Express 5, and it's running at 16x electrically. And that's where your video card should be installed. To reiterate, 2 points on the RTX 4000, actually 3 points. Number 1, those things are huge. Number 2, they're still PCI Express 4. And number 3, they've got a connector that's PCI Express 5 for power that's only good for 30 insertions. So you might want to think twice about doing something like that. But we always say, one GPU, it's a lot simpler. Oh, another point I forgot to point out. NVLink is not going to be supported on the RTX 4000 series. It's only on the RTX 3000, or you have to go to the professional cards for the NVLink, which allows you to put 2 GPUs and work them together. They claim, I'll see if I can find the link, that they're going to use that for something else because they didn't think it worked as well, and they got something else that's going to require the I/O. Yeah, right, okay. Call it what you will. I think they're trying to differentiate consumer video cards versus professional video cards. And if you're building a consumer desktop motherboard, you're better off with an RTX 3000 series something, unless you want to go with one of the professional cards. But if you're going to the professional card, then I say build a workstation. That's my 2 cents. Have to put that in there. Okay, 3 slots. First slot to the CPU. We have a second slot that is a 16-lane slot mechanically and physically, but electrically, that's a 4-lane slot. And the third slot, which, to reiterate, is a 16-lane slot physically and mechanically, is running 2 PCI Express lanes. Those are chipset lanes, so that's 6 PCI Express lanes. And then we will also, oh, and here's another real goodie we'll look at on the block diagram. That third slot, PCI Express by 2, shares bandwidth, so we need to look that up, sharing bandwidth with the SATA 3, 4, and 5 connectors. Now, typically, a SATA port is 1 lane, so 2 SATA ports should be 2 lanes. That's where the math gets a little weird. We'll see when we get there, so keep that in mind. But SATA ports are not as big a deal as they used to be, but they are still necessary. You'll still have plenty. Now for the storage. One M.2, PCI Express 5, and a second M.2, also PCI Express 5. Both of those are 4 lanes, and it's interesting that it says those could be a 2-lane. I've never seen a 2-lane M.2 NVMe drive. We have seen some computers in the past when we first got access to putting an M.2 NVMe on a motherboard, where this goes back to the 990FX chipset, where when they put out the second iteration of those motherboards, they allocated 2 SATA ports, which they removed. So instead of having 6 SATA ports, we went to 4 SATA ports. But to reiterate, they took those 2 SATA ports, which was 2 lanes, reallocated that to an M.2 slot. Okay, that meant we could go like 1750. We couldn't do 3,500 megabytes per second on a drive. And to reiterate, at the time, we did not, because it was less expensive, and we had the option on an M.2 connector to go 2 ways. The M.2 SATA or an M.2 NVMe. At the time, which I guess is about 8 or 10 years ago now, we went with M.2 SATA because it was less expensive. M.2 SATA was still faster than a SATA 3 spinning drive, a whole lot less expensive. And then we went with the next iteration. Then we started embracing, when we had the 4 full lanes, to then go with the M.2 NVMe. It just didn't make sense to use 2 lanes to upgrade the system just for that one feature to get to 1750. So we waited. I think all these little details matter, so as you're looking at this stuff, you're trying to figure out, what, why, and how, it'll kind of make sense. That's the goal. So to reiterate, 2 M.2 connectors to the CPU, and those will be defined as we look at the manual, M2A_CPU and M2B_CPU. And every motherboard allocates this stuff different. Okay, the other 2 M.2 connectors can be 4-lane or 2-lane, and those are M2C and M2D_SB. SB for South Bridge. Sometimes you'll see the term PCH for Platform Controller Hub. All 3 of those terms mean chipset. And 6 SATA connectors, but remember, 2 of those SATA connectors are reallocated based on that third slot that goes through the chipset. So we're good on, to reiterate, if no one's noticed, we're good on CPU lanes. Those are dedicated and those are hardwired. But the chipset lanes is where we've got some monkey business going on. And that's where we get into some shared resources. So pretty good so far. And this will support RAID 0, RAID 1, RAID 1.0 for NVMe or SATA. Now, another question that comes up, what about RAID? Okay, RAID, the specifications, if you're going to do, and this is, what's the best way to put this? These machines, consumer desktop as well as the other levels, can do a what's called a CPU-based RAID. And in this category, where we divide that, versus a GPU-based RAID, which is another technology we've talked about in another video. But for a CPU-based RAID, you've got 2 options. It can be a hybrid BIOS bootable RAID, which involves the BIOS, 1 to bifurcate the slot, and 2 to turn on RAID. Or number 2 can be an operating system RAID, which number 1, if you're doing a quad card, you have to, again, enable bifurcation, so you see all 4 of those drives. Then you go into the operating system. But then the question becomes, what drive are you booting off of? So the hybrid BIOS bootable RAID is faster. A software RAID is easier to configure and install. But when you're trying to figure out where you're going to boot from, the expectation on a motherboard with the default install is it's all or nothing. To reiterate, either everybody's in RAID or nobody's in RAID. So you have to keep that in mind, and we have a video about how to do that separate, which deals with that on the TRX40, where we had 5 drives. 4 in RAID, 1 was not in RAID. Non-typical, but separate video. So as we look at this for these RAIDs, the third type of RAID that would be a CPU-based RAID, would be a hardware RAID, which would be a card that has its own BIOS on it. Now, on a consumer desktop motherboard, I wouldn't spend that kind of money on one of those kind of cards. You're looking at something like a Broadcom card, like a Mega RAID. There's other brands, but that's usually the easiest one to find based on resources, based on availability. I won't get into the other, separate video. But for what's available to do with this motherboard as it comes shipped, you can do RAID, to reiterate, hybrid BIOS bootable RAID or an operating system RAID. And it can be RAID 0, which requires 2 drives or more. It can be, which is what I call RAID by the seat of your pants, which is about speed and capacity, which is what everybody wants. So these motherboards will support the 8 terabyte drives and anything below that, whether you get PCI Express 3, 4, or 5. Your speed is going to be governed by the chipset and based on the location, whether it's on the M.2 to the CPU or the M.2 through the chipset. The next thing you're looking at is the specification of the drive, whether it's PCI Express 3, 4, or 5, as the speeds I've outlined. So you're only going to get the speed of the drive that's capable, and chain being only as strong as the weakest link. If you're on CPU lanes and it's PCI Express 5, you'll get that speed. But if you got a PCI Express 5 drive, you put it on the chipset, you're only going to get a speed that the chipset can handle, which is PCI Express 4, not PCI Express 5. So keep all that in mind. These questions get asked, they always come up, so I want to try to address them and help as many people as we can. Love my subscribers. Now to the CPU, the one USB-C port, and that particular USB-C port is 10 gigabit, and that's also the DisplayPort Alternate Mode. And then also through the CPU, which is kind of weird, I think, is the USB 2 hub, but it's there. And then we've got the USB 3 ports also through the CPU. Those combined, that port should be, for what it's worth, that one port alone should be 2 PCI Express lanes that we're not going to be counting as we get into the document, but I do anyway. And this other stuff should equal out to, these should be 5 gigabit ports, so that may be as well 2 lanes, or it could be 4 lanes, depending on how they're allocated. But my expectation would probably be 2 lanes there, and these also 2 lanes, and then this USB 2 would be piggyback on that, so that's a total of 4 lanes. And then down through the chipset, USB, whenever you see 2x2, that's 20 gigabit. 20 gigabit, 4 lanes, period. And then you've got your other ports, and I would expect all these other ports combined, probably 4 lanes total for all that. So that'd be a total of 8 lanes through the chipset. And also the chipset, these other USB ports. And since they are, that'll be USB 3 generation 1, those are 5 gigabit, that should be 1 lane per port. But those are not the lanes we're going to be counting. We're looking at slots and storage. But I just kind of want to go through some of this. Now, something else we need to pay attention to here, and this goes to the third add-in card, internal I/O connectors. Okay, there's the 20 gigabit port that gives you a header to the front. But what we're looking for right here is THB_U4 add-in card connector. On the Extreme motherboard, I looked at that 3 or 4 times before I found this, because on the features, in the features section of that Extreme motherboard, there was a comment about Thunderbolt 4, but Thunderbolt 4 was not listed anywhere else until I went to the specifications, found this, which is the same setting. What I don't know is which card it's going to be, whether it's, as I mentioned before, to reiterate, the Intel chipset, which is Intel Thunderbolt 4. Now they're calling it the Intel, because it's still Maple Ridge, but now they're calling it, to reiterate, the Intel USB4. Just some lipstick. Or if it might be the AS Media, I don't know. In the documentation, if it was referred to specifically by brand, then we know the chipset. So I say this because of the third add-in card you might want to put in as we get to the slots. That would be that third card that will work on chipset lanes, and it can work in PCI Express 3 or maybe PCI Express 4, because that's where we have to differentiate. So as we're looking at PCI Express 3, to reiterate, or PCI Express 4, for USB 4, the first requirement for version 1 is 4 lanes PCI Express 3, which is supposed to be able to get up to 65 gigabits. And for those that know where I'm going, give me a second, I'll get to it, because it's based on PCI Express 3. However, version 2, that's based on PCI Express 4, 4 lanes. So version 1, 4 lanes of PCI Express 3 versus 4 lanes of PCI Express 4. Why is that relevant? Okay, the longer that card takes to come out, the more likely it is to be version 2. The quicker that card comes out, the more likely it is to be version 1. If it's PCI Express 3, the slot, according to what I think we're going to read, we'll double check, is a PCI Express 4.0 slot. And because of that, we're still trying to figure out a lot of stuff that we're not told. Because it's a PCI Express 4.0 slot, it behooves us to wait until that version 2 card comes out, because The version 2 that's going to use 4 lanes of PCI Express 4 is supposed to be good up to 80 gigabit. How are they going to do that? More smoke and mirrors. Because remember, Thunderbolt 3 and Thunderbolt 4, 40 gigabit, is based on bidirectional bandwidth. So if you're implementing Thunderbolt 3 and Thunderbolt 4, which USB 4 now will do, and there's been a differentiation in the chipsets of not just chipsets that support USB 4, but the other feature was USB 4 tunneling over PCI Express. And that's something else you're going to look into the BIOS. Because if you've got one chipset that supports USB 4, it may not support the PCI Express tunneling that will be in a later chipset. And because this is even later, a newer chipset, now they're calling it USB 4. So revision 1, revision 2. And remember, Thunderbolt 3 and 4, now USB 4 version 1 is based on PCI Express 3, which is 4 lanes. So how do they get the speed? Because it's only good for about 32 gigabits. I'm just telling you what it is. So, you know, all these little things matter. And as one subscriber pointed out, a device that is spec'd for Thunderbolt 3 or Thunderbolt 4 can have a speed or a bandwidth of only 20 gigabit and still qualify as that spec, which stands to reason because it's only good based on PCI Express 3 to 32 gigabit. So if you're talking 20 gigabit, now you're back to USB-C 20 gigabit. So I would do the math and implement whichever one is the simplest and easiest to do. I'm just sharing with you what we know and the specs because, you know, all these little details, absolutely fascinating. Lots to think about, lots to watch. And you may want to watch this again and go over some of the stuff. And if we've simplified some things for you, great. If we've complicated it, that's a bummer because that was not our goal. But if you're hearing this kind of stuff for the first time, then that's a lot of information to soak in because we've been doing this a long time. And the more we do it, the better we get at it. And I always say chipsets rule. If I know what a chipset does, I have a pretty good idea of what the CPU can do. And that's where I started realizing what we had with consumer desktop motherboards, how limited we are when we go to a high-end desktop comparatively, and we go to a workstation comparatively. Workstation is the best bang for the buck. More. So that takes care of the Thunderbolt 4 connector, which is an add-in card, which will be available later separately. How soon or when, we don't know. Let's go up here to support, and I really appreciate Gigabyte has provided the information we need. The motherboard manual we need, it's generic. I'll show you the one setting in there that relates to bifurcation. But we've also got a CPU support list, which is the same we have in the article. So there's nothing new, but it's a corroboration of information. Nice to know. Some of the other vendors are not putting this stuff out yet. Don't know why. Let's go to manuals. Okay. There's a unique features introduction. Those unique features, we're going to need that. There's a feature some of you guys have asked about that as we see the connector on the motherboard, this time I'm going to identify it and I'll tell you what they say about that information. The documentation is there, but you got to dig for it. And based on what Gigabyte tells you where to go looking for it, it ain't where they say it is, but I'll show you where it's at. I'll give you a heads up. It's under fan control, but we'll get there. Manual number 2. There's a BIOS setup guide. It's generic. We need it to reiterate. Manual number 3. There's a RAID setup guide. We don't need that for this, but you'll want it. We're going to spend most of our time in the motherboard manual. And in the motherboard manual, first thing I want to do is go to page 3, which is contents. So we can go through real quick. Number 1, motherboard layout. Number 2, motherboard block diagram. Number 3, product specifications. And of those 3 items, as we're going to go through and reiterate some of the information we know, so we can go 1, 2, 3, the block diagram is the most fascinating. We're also going to be looking at, and I'll say this according to the spelling, shares bandwidth. If we did a search for bandwidth or shared bandwidth with a D, we wouldn't find what we're looking for. But we need to understand how those, not only the M.2 drives are connected, but how those SATA ports with those lanes for slots and storage, how those get rerouted. That to me is a bit of a conundrum, but I'll show you what it says. We've also got this other feature in the BIOS that deals with fan control, and that's the noise detection control, which is interesting. That one little header in there on the motherboard that some of you have asked about, it will check the sound. Now, that's one of those things, if you're looking at noise detection, you'll want to check your decibel level and compare to see how accurate it is. You got to wonder. But it's a feature that's on the motherboards now, which is kind of nice. But to me, some of this noise that a computer makes is like white noise. If you're building a digital audio workstation and you need quiet, then you've got to figure out some way to not only make the machine quiet, but also you want to use larger fans that move more air that don't have to run at such a high RPM. All those little details matter. So We're going to also take a look at that motherboard header for Thunderbolt USB4. I mentioned the lanes and also the back panel I/O connector. Let's get to the motherboard layout. I like to see where things are at. Motherboard layout. Okay, 4 DIMMs, dual channel, and we don't know if the 7000 CPU has solved the problem of the memory controller that we had on the 5000 series. To touch on that real quick, if you had 4 DIMMs on a 5000 series processor, you took a performance hit versus using only 2 DIMMs, and you had to decide, did you need more RAM or you didn't need faster RAM? What we don't know is if that problem has been solved on the 7000 series. I hope so you can use all 4 DIMMs to get to 128 gigs. But if you need more than 128 gigs, you need to go to a workstation. Okay, slots and storage. 1, 2, 3 slots. Now, all 3 of these slots, to reiterate, are 16 lanes mechanically, physically, but electrically. If you notice here, and this is what I appreciate, that says PCI Express by 16, which is 16 lane slots electrically. This one right here, PCI Express by 4. Even though it's a 16-lane slot mechanically, electrically it's only 4 lanes. And this bottom slot, to reiterate, is 2 lanes, these M.2 connectors, and of which we have 4. M2A, M2B, underscore CPU, and then M2D and M2C, underscore SB. And over here on the far right side of the motherboard, we'll zoom in on that, we've got the THB underscore U4 connector, which is a 5-pin header, which, long story short, we went from a 5-pin header on Thunderbolt 3 with Gigabyte to a 5-pin 3-pin header on Thunderbolt 4, and now we're back to a 5-pin header on USB4. Oh, confusing, crazy. And the questions we fielded with that are just a conundrum. Anyway, we simplified it, and just under that is the noise detector. And that noise detector sensor looks like it's going to be 2 pins, which is a separate cable. I'll go back and take a look at it now that I've mentioned it. It's a cable that's got intertwined with a kind of a fitting or something looking on the end of it. Anyway, that's one of the items in the motherboard, so in the box. So when you get your motherboard, first thing you want to do is put a camera on it and make sure that you receive what you've ordered. And number 2, you want to take inventory of your parts, because if anything is missing, when you're dealing with a vendor, what they're going to say is RMA, send it back. And if you're trying to build and you're missing something, you've got some downtime where parts you're waiting on and everything won't line up in terms of does everything work. So remember those 2 ideas, or those 2 items. Let's look at that sensor. Now the first sensor we'll find in the specs are 2 temperature sensors, or 2 thermistors. I hope they're both useful. We've had problems in the past, like with this machine, where we had 2 thermistors, or 2 sensors, that we could use, but when you go into the BIOS to try to configure those, one of them, based on the settings, was absolutely useless. The other one was good, but it'd be nice to have had both of them. So I hope both of these are going to be useful with whatever settings they've adjusted for in the BIOS. But I want to point that out. Okay, the noise sensor, this is on page 32, and you got noise detection and ground, and you can see how that like an intertwined cable. It plugs in, it's keyed, so you shouldn't have to worry about getting it put in backwards. And it's a 2-pin connection, and it's in between, to reiterate, the Thunderbolt USB4 connector and then your SATA ports, of which there are 6. And since we're covering that sensor, right up here under this manual for unique features, in that manual, under fan control, right there, using fan control, there's a setting for noise detection. Provides detection of the noise level measured in decibels inside the chassis. Now to use the noise detection function, you have to have a motherboard with a noise detection header. Yeah, no kidding. And I don't know how well that shows up, but that gives you an idea of what you're looking at. Our primary concern is if we can do this from the BIOS, great. If we have to have extra extemporaneous software installed to be able to read something like that, that's not so great. And there's another setting that's in the BIOS that we're going to get to as I go through some of these items, where there's a feature for Gigabyte software. ASUS is doing the same thing on their WRX80 workstation motherboard, where that if you install the expected operating system, which is Windows, that application is turned on in the BIOS that will install that stub. If you're trying to figure out how to uninstall it, if there's no uninstall routine for it, it's because the setting in the BIOS that keeps it there, persistent, which I don't like that. Now, I appreciate features, but I don't like extemporaneous software, because if you've ever had a BSOD, you know what I'm talking about. I'm only interested in what I need to do the job I'm after, because it's all about function for content creation, for rendering, for a purpose-built computer. Noise detection is a nice idea, but if I can control it from the BIOS, that's my preference, along with fan control. And in the box contents, you'll see your 2 thermistor cables and 1 noise detection cable, as well as everything else that's listed. Be sure and inventory. Now, from motherboard layout, we can see we have the primary chipset and the secondary chipset. Let's go to the block diagram, and this is where things get interesting. Okay, again, how many lanes are we working with? According to AMD, 24 PCI Express 5.0 lanes. According to this article, 28 lanes. Okay, notice the bold black line. 16 lanes, 4 and 4. 16, 20, 24. There's our 24 lanes. That's M2A underscore CPU and M2B underscore CPU. So a 16 lane slot, first scenario, a quad card, that's where it has to live. If you put a GPU in, that's where you're going to want it to live, but you can't have a quad card. And the third option for the third slot, we'll get to. And if you want to try to add up your other lanes, right there's the USB-C port with DisplayPort Alternate Mode that we talked about to the CPU. That should be 2 lanes. And I have to also remember that the lanes that go from the CPU down to the first chipset, remember those lanes are supposed to be CPU lanes that are PCI Express 5 downgraded to PCI Express 4 for that primary chipset. And the CPU only connects to the primary chipset. The secondary chipset connects to the primary chipset, which then connects to the CPU. So anything that goes through this secondary chipset has to connect to that primary chipset before it connects to the CPU. So you can do the math, figure out how it's going to get there. To me, it gets a little bit weird. But if we're counting just the lanes they're talking about, off the bold line to the left, and that gets us our 24 lanes. Okay, let's go down now to the chipset, primary chipset, Promontory 21. The bold line, M.2. This is PCI Express 4.0, 4 lanes, see it right there. And we know that's M.2, which is M2C underscore SB. We have 4 SATA ports right here. So that's 4 and 4, that's 8 lanes. If we try to do the rest of the math, over here on the right, we've got a USB-C port. It doesn't tell us, but we know that's supposed to be 4 lanes. So if we're supposed to have 8 lanes in this chipset, there's 4, there's 8. Or are they counting 4 and 4? That would be 8. And if there's a total of 16 lanes in here, you can figure out how that goes. Because remember, these lanes that connect this chipset to that CPU, those lanes are coming from the CPU. So there's 4 lanes that drop down that connect to the second chipset. I'm just showing you the way the mapping goes. So that's an M.2 drive, which is M2, to reiterate, M2C underscore SB. Then we have the fourth one. Let's go down to the last chipset. We have a bold black line to the left and a bold black line to the right. PCI Express 4.0, 4 lanes for a 4-lane slot and 4 lanes for M2D underscore SB. Nice. And that's 8 lanes. So if we're supposed to have, so according to this article, if we count that we have in the secondary chipset 12 usable PCI Express lanes, let's see how that maps out. 4 and 4 is 8. This USB-C port up here should be 4. And we have, we'll get to the switch in just a minute. Here's this 2-lane slot. So that's 2 lanes, 3, 4. There's 4 lanes, so 4, 8, 12. That's our 12 lanes that they're counting. Well, that's 4 lanes, and what we don't know is it looks like how they count the lanes, what's connecting this chipset to that chipset. I would expect the primary chipset is using its lanes to connect to the secondary chipset, but I don't know that for a fact. So I'm going to count what we're told, 4, 8, 9, 10, 11, 12. 12 lanes. Those are the 2 bold lines. Now, PCI Express 4, and over here PCI Express 3. M.2 Wi-Fi, Intel 2.5 Gigabit Ethernet, and right here we have a switch. 2 lanes. Those 2 SATA ports, because they're on a switch, can be either this slot or those 2. I noticed on the ASRock motherboard, I got to mention it because it's in my head, they show 2 lanes, but they talk about it as if only 1 lane is allocated. It's a little bit confusing, but I want to mention it because it'll come up, because that may be the next motherboard we look at, even though we don't have a BIOS manual. We have a motherboard manual we can look at on ASRock. But the 2 to reiterate I want to look at are ASUS and MSI based on the description and specifications. Because even though we're generically 3 slots and 4 M.2 drives, the way they're doing slots and storage for adding storage looks pretty fascinating. More. So I'm just showing you what they give us and showing you how it works. Now that slot, which is PCI Express 4, another way to look at this, and I'll leave this up here so you can stare at it. That's where you would put the USB4 card when it's available. Right now, if it's version 1 of USB4, you don't need PCI Express 4. You only need PCI Express 3. So my question, and I'm wondering, if that card, to reiterate, the longer it takes to come out, because this is a PCI Express 4 slot, USB4 version 2 will require PCI Express 4. So the longer that card takes to come out, it's going to work on that motherboard. But we don't know. all this information, all these specs, this is up for conjecture. So I just want to show you the facts and what we're looking at and how we're looking at these. I like the Extreme motherboard. I think I like this Master a little bit better because of the one feature. But the one feature they've added, which is kind of interesting, my personal, I would rather have the Extreme because it's got the 10 gigabit Ethernet. So you have to decide. Every motherboard is different, and the resource allocations are different. I didn't see any reason of getting any more into the specs. I didn't see any reason this time to show you the setting in the motherboard BIOS, which tends to make me think we'll go ahead and do the ASRock motherboard and look at it, because there's a setting in the BIOS for bifurcation. You got to turn that on. So there are 3 add-in cards. If you put in a quad card, you know what to expect. If you don't put in a quad card and put in a video card, or if you want to use the onboard GPU because of the DisplayPort Alternate Mode, you know what to expect. And if your third option is that USB4 card, like the quad card for PCI Express 5 that Gigabyte has announced, I'd expect it to be a year off. Because remember, Gigabyte has announced the PCI Express 4 card that takes 8 drives, which means it's a self-bifurcated card. It looks like it's based on the High Point card. Why does that matter? It's still not available yet. So all these things are in a state of play. These motherboards should be out by the time you see this, but if you're looking and your mouth's watering and trying to make sense of this, this is about slots and storage for content creation, on how everything fits. 3 slots, 3 scenarios on how to use those slots, 4 M.2 drives, and how those are wired, CPU versus chipset. So I hope you enjoyed this. I want to thank you for watching. My name is Gil Boyd. This is BuildOrBuy. Welcome. We'll look forward to seeing you next video. We're out.